So in today's lesson, we're going to be able to solve linear equations and verify solutions. So let's think about the link between simplifying expressions and solving the equations. So here we have an expression to evaluate, n plus the quantity n minus 1 squared. And this is if n is equal to 3 and n is equal to negative 4. What we'd like to do is try to find the error or errors in the simplification process when we're evaluating the expression with those values for the variables. So we know when we're evaluating, we're going to substitute the values in for the variables into the expression. So every place I see m, I'll substitute a 3 in, and n, I'll substitute a negative 4. So this first line here, we have done just that. So then we want to think about, well, from this point here, what should be our next step according to our order of operations? So we said look for grouping symbols, which we have here, and attached to the grouping symbol, we have a power. So let's think about this. We know that we're supposed to simplify the grouping symbol before applying the power. So a negative 4 minus 1. So think of the number line. We're at negative 4. If we're subtracting 1, we're going to the left 1 unit, right? We're thinking about adding that negative 1 to it, so that brings us to negative 5. So then we have to think about the power. Now, it's negative 5. Remember, that was inside the grouping symbol, to the power of 2. Now if we look at how it's written, that's not what it's saying here. This power of 2 is attached only to the 5, not the value that we have at negative 5 on our number line. So that's where our error is at, in that line of our problem. So we really want to think about it as this. Negative 5 squared means we have negative 5 times negative 5. That will be a positive 25. And then we're adding 3 to it, so 3 and 25 gives us 28. This is the correct evaluation for the expression that was given. So as we're solving, we want to think about those processes that we use for evaluating and make sure we're doing them in the correct order to arrive at the valid solution. If it's an invalid solution, remember that will show up in our check and we'll know we have to go back and find where the error is. So here's our first equation. We have 8x minus 3x minus 10 equals 20. And so we want to find the value for x that makes this true. So as I'm looking at the problem, the first thing I see is that we have some like terms that can be combined. 8x taking away 3x, that would be 5x. Let's think of this as 5x minus 10 equals 20. So the next step for solving the equation is to undo the subtraction. So we're going to add 10 to each side of our equation. So now we have 5x equals 30. To undo that multiplication, we'll divide. And if we divide each side by 5, we'll have x equals 6. So remember, to check that this is valid, we're going to substitute the value of 6 into the equation and evaluate it. So we can see in the original equation, we have two places where we have to substitute the 6 into. So we've got 8 times 6, that's 48. A negative 3 times 6, that would be a negative 18. We have our subtraction of 10 equals 20. So again, we're just going to think about left to right. 48 minus 18, that's 30. 30 minus 10, that's 20. We have a balanced equation. So the value for x that we have here is true. X equals 6. So let's try another one. Here we have 4x minus 7 times the quantity x minus 2 equals 26. So again, let's think about how we would have to evaluate this. So we'd have to distribute the negative 7 to each part of our quantity here. So we would have a negative 7x and a positive 14, because a negative times a negative would give us a positive. We're going to look to see if we have any like terms that we can combine. And this 4x taking away 7x would give us a negative 3x. So we have negative 3x plus 14 equals 26. Now, in order to solve, we have to get x alone. So we're going to undo this addition by subtraction. Subtracting 14 from each side of the equation brings us to negative 3x equals 12. To undo the multiplication of negative 3, we're going to divide by negative 3 on each side. And we know a negative divided by a negative is a positive. And a positive divided by a negative is a negative. So we have x equals negative 4. Now we have to verify this is the correct value of x for our equation. So we're going to substitute -4 into the original equation. So that means we're going to substitute it here and here. So let's think about evaluating this equation here. So we can simplify what's inside the parentheses. -4 minus 2, that's -6. And we also know that 4 times -4 is -16. So we can multiply these together here. -7 times -6 would be a +42. A -16, a +42. That does give us our 26, and therefore we have the correct value for x for our equation. X equals -4. So let's try this equation. We have 6 minus the quantity x plus 7 equals 4. So we have to think about this, subtracting a quantity. We're taking the opposite of what we have here. So you can think of a -1 being distributed to each piece. So we'd have 6 minus x minus 7 equals 4. We have some like terms we can combine here. 6 minus 7. That would give us -1. So we have a -1 minus x equals 4. Or perhaps you wrote it as a -x minus 1 equals 4. Those are the same things. Now we're trying to get x alone, so I can add 1 to each side of my equation to undo that. And then we have a -1 times x, so to undo that we'll divide by -1. So a negative divided by a negative is a positive. And a positive divided by a negative is a negative. So x equals -5. Again, to verify that this is true, we'll substitute it back into the original equation where we see x and make sure it's balanced. We're going to put our -5 here. So we have 6 minus the quantity of -5 plus 7 equals 4. Well, we know, simplifying inside those parentheses first, -5 plus 7, that will give us a 2. Then we have 6 minus 2, that would give us 4. And so it's balanced. This is the correct value of x that makes that equation true. All right, here's another equation for us. We have 3/5 times the quantity 3x plus 5 equals -24. So we have to take 3/5 of each part of that quantity. So if we want to think about multiplying fractions, we can put each of those terms over 1 again and multiply across. We'd have 3 times 3x, which would be 9x, over 5 times 1, which is 5. Also 3 times 5, which would be 15, over 5 times 1, which is 5. And that equals -24. Now, if we want to think about each of those pieces, see if we can simplify them. 9 and 5 do not have any other common factors other than 1, so that's simplified there. But 15 and 5, we could divide out a 5 from each of those, which would give us a 3. So to continue simplifying, we would have to subtract 3 from each side of our equation, which would give us 9/5 x, or 9x over 5, equaling a -27. So now at this point, we have a couple of options. We know we have a division problem here, so since it's being divided by 5, we can multiply each side of our equation by 5. So that means we would have 45x over 5, which would simplify to 9x. Then we take -27 times 5, which would give us a -135. So to undo the multiplication of the 9, we would divide 9 by each side. So we'd have x equals a -15. And at this point, we could check to make sure that's the right value for x by substituting back into the original equation. Now, if you didn't want to undo the division and then undo the multiplication, you could have done what we've done previously by multiplying by the reciprocal. And we could have multiplied by the reciprocal when we had the 9x over 5, but we also could have multiplied by the reciprocal in the very start of our equation here, because it was 3/5 times our quantity. So if we just wanted to undo that, we could have multiplied by 5/3, because that would be 15 over 15, which is 1. And then we would just have this quantity to deal with. So this is another option. either one would be fine. So remember, when we did that here, we'd have the negative 120 thirds, which would simplify to 40. So we can deal with this equation now. 3x plus 5 equals negative 40. If we're solving for x here, we could subtract 5 from each side of the equation, which would give us 3x equals negative 45, and then divide by 3, so x would give us our negative 15. Regardless on which method you choose, we still have to check and make sure that the negative 15 is the correct value that we need for our equation. So let's see. If we substitute it back in, and we evaluate it, we're going to have to do this part here. So we're going to have 3 times negative 15, which would be our negative 45. Then we have to add the 5 to it, which would be a negative 40. Then we would multiply by the 3/5. So here we have our negative 120 over 5, which we know simplifies to negative 24. So we have the right value for x for our equation, the negative 15. So we've done some solving. Let's go back and see if we could do what we did before with our evaluations. Can we find some errors with the solving? So here, can you describe and correct the error in solving the equation? So the original equation was 7 minus 3x equals 12. And we have the following steps which claim that the answer would be 3. And we know if we verify that solution, that would not be correct because we would have 7 minus 9, which would be negative 2, and that can't give us 12. So where did the error occur? Well, here's the original problem. So let's see, first step, they ended up with 4x equals 12. Well, 7 is a constant, and here we have a 3x, and those are not like terms, so we cannot combine them together. So that second step, by combining unlike terms, that gave us the problem. Well, how should it have been solved? If we go back to that original problem, what we should have done was subtract 7 from each side of the equation, which would give us negative 3x equals 5. Then divided by negative 3 on each side of the equation. Again, a negative divided by a negative would be a positive 1x, and then a positive divided by a negative would be a negative. And 5 and 3 do not have any common factors, therefore that would be our simplified result. So we know that x should be negative 5/3. Again, if we substituted this back into the original, we would want to make sure that we get back our 12, and we would. So we know we're on target with our solving. Here's another one. The original problem is 5x minus 3 times the quantity x minus 6 equals 2. Can you describe and correct the error in solving the equation? Well, if you look at your original problem here, we know that we can't do anything right now with inside the grouping symbols, but we have this negative 3 that's being multiplied by it. So a negative times a positive is a negative. A negative times a negative is not a negative, it should be a positive. So here is the error. We have a sign error when we were distributing. Okay, so we've got that distribution error with the sign. So think about what should have happened. We know that should be a positive 18. So at this point going forward, what should be our value for x? We know it can't be 10. Well, we have some like terms here that we can combine. 5x minus 3x, that would be 2x. So now we have 2x plus 18 equals 2. Again, if we're solving to undo that addition, we would subtract 18 from each side of the equation. So now 2x equals negative 16. To undo that multiplication of 2, we're going to divide each side of the equation by 2. So x should equal negative 8. And we could verify again that that's the correct value of x by substituting it back into the original equation to make sure we get it balanced with that 2 as our result. Let's try one more scenario. We know a television production company charges a basic fee of $4,000 and then $200 an hour when filming a commercial. Well, if this is how we're being charged, is there a way that we could represent it by writing an equation? In order to do that, we talk about defining variables. Variables are the unknowns. And that's what helps us when we're writing equations and solving for those unknowns. So here, what are some variables, some unknowns in the scenario? Well, if you look at your givens, it says the production company charges a basic fee and then $200 an hour. Well, we don't know how many hours are being used, so hours of filming would be a variable. And depending on the number of hours, that would determine our cost for this commercial. So that also would be a variable. Well, is there a way that we could write an equation to represent this scenario now that we know the variables for it? Well, the cost, C, is calculated by, so C equals the flat fee of $4,000 plus $200 an hour for filming. So we can think of it as C equals 4,000 plus 200H. Here's an equation to model our scenario. Well, if that's how we're being charged, let's see what else we know. We said it was dependent on the number of hours the commercial took. So if this production company recently spent 26 hours producing a Doritos commercial, what was the total cost of filming the commercial? Well, if we look at our equation, hours is represented by H. They spent 26 hours on that commercial. So if we substitute that into our equation, that will help us figure out the cost. So by substituting it in, we'll take 200 times 26, which is 5,200. We'd have to add that to our $4,000 just to get that basic fee covered, which means it cost them $9,200 for the commercial. And so that's what we were looking for. We're going to write a sentence to represent that. The total cost of the commercial was $9,200. So today's lesson, we worked on solving equations, verifying solutions, and also evaluating equations when we know about the variables. Now it'll be your time to practice.